Often, when we collect data, we find that the data is distributed in a specific pattern called the normal distribution or the bell curve. This is where the mean, median, and mode are the same, and they are at the center of our data. The picture that we have here is of 3 different data sets represented by the red, blue, and green graphs. They're similar, but they're very different. The red one's very tall and skinny, and the green one is pretty flat and spread out. So what's the difference? The similarity is that they have a mean of 6. The difference is this omega, which stands for the standard deviation. So the difference is if I have a small standard deviation like the red one, 0.5, my data is going to be very close together and everything's going to be grouped up really close to that mean. If I have a larger standard deviation like the green one of 2, then my data is going to be a lot more spread out. So the higher the standard deviation, the more spread out the curve, the flatter it's going to be. Let's take a look at an example of just creating a bell curve and how that connects with the standard deviations. So if I have a mean of 95 and a standard deviation of 12, I'm going to put my mean in the middle, 95, and then a standard deviation is 12, so one standard deviation on either side would be 83 and 107. I'm just simply adding 12 or subtracting 12. To get 2 standard deviations out from the middle, I would subtract 2 times 12 or add 2 times 12. That's all I'm looking at. So that's a bell curve with the standard deviations noted. Let's see if you can do it. Here's one with a mean of 60 and a standard deviation of 6. I'll get you started. Right in the middle of our normal distribution, I'm going to put the 60 for the for the mean. See if you can fill out what the standard deviations would be on each side. All right, let's see how you did. So I'm going to scroll down. I'm going to subtract or add that standard deviation of 6 on either side and get to 54 and 66. To get the second standard deviation, I'm going to subtract another 6 on each side, and that'll take me to 48 and 72. Now you're wondering, why do I care about that? Well, it turns out that when I have a normal curved distribution, a bell curve, the data follows something called the empirical rule. And it turns out that this is really fascinating. 68.2% of the data falls within 1 standard deviation of the mean. And even more than that, 95% of the data falls within 2 standard deviations of the mean. And a whopping 99.8% of the data falls within 3 standard deviations of the mean. So if your standard deviation is fairly small, that means you're going to account for almost all of your data if you know what the mean is. Let's see how it can be used. Here we have a set of data that has a normal distribution with a mean of 70 and a standard deviation of 8. We want to sketch the normal curve for the distribution, and then we want to answer some questions. So first, let's see if we can fill out the curve. Right? So the mean is 70. That's the middle, right? Standard deviation tells us how much to add or subtract on either side. So starting with the middle, I'm going to have a 70. Then I'm going to subtract an 8 for the first, subtract an 8 for the second, subtract another 8 for the third standard deviation. On the right side, we would add 8, another 8, and another 8 to get to the third standard deviation. Now it asks me to find the percent of data that is between 70 and 80. Well, let's take a look here. 70 to 80. 70 is the middle, and 78 is 1 standard deviation above. Just a moment ago, we looked at our empirical rule that says 68.2% of the data falls within 1 standard deviation, but that 68.2% is on both sides. If I'm looking at this data, I'm only wanting the one side of it. So between 70 and 78, I would say 1/2 of that 68, I rounded 68%, or about 34% of the data is going to be between 70 and 78. All right, now if you think you're up to the task, go ahead and pause this and see if you can answer the next two questions. What percent of data would be greater than 86? And what would be between 54 and 62? Again, I want you to recall, here's the empirical rule. One standard deviation is about 68%. Two standard deviations, about 95%. And 99.8% are within 3 standard deviations. All right, hit pause and try to answer part B and C. Let's see how you did. So greater than 86%. Well, here's the mean, 70. One standard deviation is 78. Two standard deviations is 86. So we want to know what's above the 86. So that's excluding everything that is in these 2 standard deviations. So if I look at these 2 standard deviations, that's 95% of the data, and I only want the upper half, so half of that would be 5%. I'm sorry, that would be half of 5%, which would be 2.5%. Now what about the between 54 and 62? This is the toughest one. All right, so here is 70, that's my middle, median. 54 is 2 standard deviations below. 62 is 1 standard deviation below, and I'm only looking at what's between those, and I'm only looking at half of that. So I want half of the 95 minus 68. 95 is what's in here between 54 and 86. That's 95% of my data. The 68 is what's between 62 and 78, 1 standard deviation. So I want half of 27, or 13.5% of the data.